we'll often run into situations in real life where we need to know something about the mass of a gas. For example, if you want to figure out the density of a gas, or you want to figure out what the molar mass of a gas is, maybe you're trying to identify the gas, grams has to come into play here. Now, we've been using the ideal gas law for a little while now to relate these four gas properties. How do we work the mass of a gas into this? How do we work grams into this? Well, we can do it through moles. Now, I'm going to introduce a little equation here. I'm going to call capital M the molar mass of the gas. And if I want to write the molar mass, it's how many grams you have, and I'm going to call that G for grams. So that's the mass of the gas. And that's per mole. And I'm using N for moles. So I can introduce the mass of the gas into this equation using the molar mass and the moles. How do I do it? Well, if I solve this equation for moles, it looks like this. So let's take the N there and plug this in instead. Now, this is a useful version of the ideal gas law here. I can do all kinds of things with this. One of them being figure out the mass of the gas. If I know its molar mass, I can figure out the mass of the gas from P, V, and T. So it's kind of hard to weigh a gas. Sometimes gases are buoyant. If you think about trying to weigh how much helium is in a balloon. If you try to put a helium balloon onto a balance pan, it rises, right? I mean, you're not going to get a positive mass for that because the air around it is going to be buoying it up. So you can figure out the mass of a gas from this equation, and that's a handy thing to do. For example, let's do a problem like that. Suppose I've got a balloon and it's filled with helium, and the volume of the balloon is, let's say, 22.4 liters. Let's say that the molar mass of helium is 4 grams per mole. And let's say the temperature is room temperature, 25 degrees Celsius. Now, I'm going to need to change that to a Kelvin temperature. And let's say we're at atmospheric pressure, say in Frostburg. And I want to know how many grams of helium do I have in the balloon? Alright, there's two ways I can do this. One is I can do it in 2 steps. I can figure out how many moles. And then step 2 would be to convert moles to grams. That's actually the simplest way to do this. Another way to do it would be just to plug in everything I know here and solve it for G. Let's do it this way. First, I'm going to figure out how many moles I've got. So I have to solve the ideal gas law for moles. Okay, there's moles. If I divide both sides by RT, that will do it for me. So let's put in our values here. I'm going to run into some trouble, right? Because I have to choose a value of R. I know 2 values of R. We've done this before. 8.314 pascals times meters cubed per mole Kelvin. So if I'm using pascals and cubic meters, that's a good value to use. Or 0.0820 liter atmospheres per mole Kelvin. That's another value I can use. If I choose the second value, I've got to use liters and atmospheres for my units in here. Well, now I've got liters here, so I'm going to choose this one. I've got to put my pressure into atmospheres before I plug it in, though. So let's change it into atmospheres. There was a conversion factor you had to know for converting torr into atmospheres. So it'd be 713 divided by 760. So let's see, what is that? It's 0.938. Now I've changed it into atmospheres, so I can put that in. 0.938 atmospheres times the volume, which was 22.4 liters, over R. I'm going to use this value of R. Times the temperature, which I'm going to have to change into Kelvin. So this has to be Kelvin. You add 273.15 to a temperature to turn it into Kelvin. So this will be 298.15 Kelvin. So I'll plug that in there. And then you can grind it out. Let's see. It's going to be equal to 0.938 times 22.4 divided by 0.08206 divided by 298.15. So I get 0.859. Now, let's make sure I did that right, because the units should all cancel out. Atmospheres and atmospheres cancel, liters and liters cancel, Kelvin and Kelvin cancel, and I have 1 over moles, which should be moles. So that tells me that I did my algebra right. I mean, if I'm figuring out N, it better come out to be in moles. Okay, now step 2, convert moles to grams. Well, it's helium, so I know what its mole mass is going to be. It's about 4 grams per mole. So 0.859 moles. I need moles on the bottom and grams on the top. So I just multiply 0.859 by 4, and I get what? I get 3.44. So I can figure out what mass of gas I've got without weighing the gas. If I measure the volume, temperature, and pressure, and if I know the molar mass, I can figure out the mass of the gas.